Hello, ladies and gents. Welcome to Academy by Okasha. And today we'll do paper one from October, November 2024. Paper one, variant one. So that's the goal for today. And the most important thing is it's been quite a while that I've seen this paper before. Okay. So I don't know what the paper is going to look like. And that's a good thing. I'm doing this on purpose because I don't want to give you ready-made solutions. I don't want to give you the solutions that are sort of premeditated and I'll just do the working with you because this is what everyone does out there on YouTube. And also, this is what marking schemes are for, right? So I don't want to give you that. Instead, I want to look at the questions fresh, just like you're doing while you're watching the video. And so that you can sort of look at the question, but also look at the thought process that goes on behind it. Okay. And if I mess up, if I make a mistake, that's a good thing because nobody's perfect and everybody makes mistake in the exams, right? So how to correct the mistake, how efficiently you correct a mistake, how quickly you realize that, okay, I'm going to make a mistake, maybe I should redo it. That's the goal. Okay, so without further ado, let's jump in. So here we have the paper, I think. Yeah, there we go. Cambridge O-Level, Mathematics, Syllabus D, of course. And 4024, paper one, variant one, that's the deal, October, November 2024. And the time allotted, and this is paper one, of course, this is the non-calc paper. So a specific instruction for this paper is you're not allowed to use any calculator. So that's what I'll try to do as well. We'll not try to use any, of course, we'll not just try, we will not use any calculators at all. Okay, so, all right, let's move on to the first question. At midday, so we're talking about the temperatures. At midday, the temperature is -2 degrees centigrade. That's, sounds like we're in Canada. At 6 p.m., the temperature is 4 degrees. Still quite cold. Find the difference between the temperature. So how do you find the difference between them? The way to find the difference between them is you take a final value. The difference is calculated by, in general, the difference is final minus initial. Okay, sometimes the difference is big minus small as well, but mostly it's final minus initial. Okay, whenever we're talking about progression, if something is happening in time, something happens before and something else happens after. So you take the final value and you subtract it from the initial value. So at midday, so this is midday, which means this is about 12 p.m., something like this, noon, right? So this would be initial value. And 6 p.m. means this is the final value. So if you do final minus initial, you would do 4. Now you have to be careful here. 4 degrees, I'll write degrees after, minus, and then with initial, we already have another minus sign. Okay, so make sure to put 2 negative signs. You know the negative is positive, so 4 plus 2, and the answer will be 6 degrees. So 6 degrees is the difference between the two. You can realize on the scale as well. If you look at the scale, I said there is 0, there is -2, and somewhere over here it is 4 degrees. So you can already tell the difference between them is 6 degrees. Okay, in other words, there are 6 steps. -2, -1, 0, 1, 2, 3, and 4. So you can already count. You'll have to, there are 6 steps between -2 and 4 degrees. The temperature at midnight is 9 degrees lower. Lower means I'll do a subtraction. At the temperature at midday. Okay, so what's the temperature for midday? Of course, this is the part B of the same question. So we'll take information from whatever is given initially. So midday, the temperature is -2 degrees. I can already tell the temperature is -2 degrees in midday, right? So I'll pick the temperature midday, and because it is lower, 9 degrees lower, so I'll pick -2, and I'll subtract 9, right? Because the temperature is lower than -2, even lower than -2, it must be freezing cold. So -2, -9 would be -11 degrees centigrade. Like, you don't have to write degree centigrade over here, degree Celsius, because it's already mentioned. Okay, so there goes question number 1. That was a good warm-up question, pretty easy though. Question number 2, Amber and Pablo share $280 $280 in the ratio 2:5. So just from the looks of it, it looks like that $280 is the total amount. Right? This is the total amount. Okay. How many total shares are there? Okay, for example, if we were to divide it in 7 shares, right? Try to 1, 2, 3, 4, 5, 6, 7. Let's say we have 7 shares altogether. Sorry, yeah, gives 7 shares, out of which 1, 2, 3, 4, 5 of them are given to, I mean, it's actually 2:5, so I'll write the 2 ratios first. 2:5, so the 2 parts is given to Amber, and 5 parts will be given to Pablo. Okay, so this is Amber's share, and this is Pablo's share. So Amber's share is 2 parts, right? Pablo's share is 5 parts. Okay. How many parts are there in total? Total 5 plus 2 is 7 parts. So think about it for a while, right? Altogether 7 parts, altogether amount is $280, right? So 7 parts, if I were to make a proportion, I'll say parts and amount. Okay. So if you have 7 parts, 7 parts equals $280 because that's all we have, right? And Pablo's share is 5. So if 7 parts is $280, how many parts would be 5? What's the amount for $5? So for 5, if $7, 7 parts is $280, what's the amount for $5? I don't know what it is, so I'll put that an X and I'll do cross multiplication. Okay, that's the simplest trick. So if I were to do cross multiplication, 7 will be multiplied by X, so 7X would be equal to 5 multiplied by 280, X equals 5 multiplied by, you do not do the multiplication over here. Make sure that you isolate X, right? And then perform the multiplication, right? So that would make it easier for you to, for cancellation. Okay, 5 multiplied by 280 divided by 7, how would I cancel it? We're not allowed to use the calculator here, mind you. So 7 times 1 is 7. I think 7, yeah. 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28. So that would be 14, right? So I'm left with x equals 5 times 40. So I think 5 times 40, 5 fours are 20, so that would be 200. $200 is Pablo's share because we found out the value of X. X was actually Pablo's share. So that's that. Okay, I'll write total here. So there was the total and that was Pablo. Okay, so there's that. We worked out the Pablo share over there. Next, here are 8 integers. So we have 8 integers. Remember, if you remember integers is all the positive values, all the negative values, but not the positive values and the negative values, but not the decimals and fractions. Okay. So here the decimal, what's the mod? Mod, we know the mod is the most repeated value. Most repeated value. So 1 is repeated 1, -1 is repeated once. -1 is repeated twice and thrice. Any other number which is repeated? -3 is twice. I think the mod should be -1 because it is repeated thrice. I don't see any other number which is repeated more than 3 times. So I'll say my mode is -1, right? Median. So median is actually the middle value in an arranged sequence. Arranged sequence. Okay. So a very obvious mistake would be to find out the middle value from here right away. That's not how you do it. You arrange them first. So middle value in an arranged sequence. So you can arrange in any order you want. You can arrange in ascending order or descending order, big to small or small to big. It doesn't matter. I'll go from big to small or small to big. So the smallest one over here is -7. So I'll put -7 here. -7 is the smallest, right? Don't be fooled by the number. It's -7, so it must be the smallest. -7, then we have -5, then we have, I think, -3 twice, and then we have -1 thrice, -1, -1, -1, and then we have, I think, so we're done with this, we're done with this, and then we have 2, I think, yeah, 2. Okay. So how do you find out the middle value? Well, I would it's like cutting from both sides. You cut from both sides until you reach a middle value. So I'll put a cross on either sides, cross, 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 and I'm left with 2 numbers. Okay. If I were to cross both of them out, I'll be left with nothing. Okay. So a sensible thing to do over here would be to take the average of the 2 numbers, -3 and -1. So average means you do -3, -1, you divide that by 2. Okay. So -3, and in other words, you can think about it this way. What will be between -3 and -1? It will be -2. Okay, it makes sense, right? Between -3 and -1, we have -2. But you can also work it out. If you were to solve it, -3, -1 is -4 divided by 2. I'm going to get -2. So -2 is my median. It would be better if you work it out instead of just writing it. Right away, working never hurts. Not if you're running out of time. Okay, so this was pretty simple as well. I don't think it was that difficult. Right, shade one small square. So the diagram has one line of symmetry. So what is one line of symmetry? Line of symmetry, I mean, you think about it as a handkerchief. Okay, if you ever owned a handkerchief or a tissue paper for that matter, it's like if you fold it let's say you make a crease from the middle, and if you fold it, this side would exactly align with the other side. This would come, this side would become would lay itself down exactly on top of each other. So this would on top of each other, this would on top of each other. So you will have this line of symmetry. Okay. And this line of symmetry divides this shape into 2 equal parts. That's the deal. Okay. And so that's the line of symmetry. If you look at this line of symmetry, right? One has one line of symmetry. We don't even know which square to shade, right? Shade one more small square. So we don't even know what square to shade, and we don't even know which is the line of symmetry, right? So that's kind of a what it's called, two-sided question where you have to first work out the line of symmetry, and then if you can work out the line of symmetry, then you can work out, well, which square is missing, and you can then shade that square. So I'll start with the most obvious ones. Line of symmetry can either be vertical, okay? Line of symmetry can either be horizontal, right? And if both of them don't work, you look for the diagonal line of symmetry on both diagonals. Okay, these are the most obvious, most possible. This is something you look for the first. Okay, so it can be either horizontal or vertical, or this diagonal or this diagonal. Okay, so let's see. I'm just testing it out. I'm not sure which one is the line of symmetry, but let's just see. If I were to draw a line of symmetry right from the middle, so we have 2 boxes up, 2 boxes down, right? And we have the box. So I'll cut my line of symmetry. I'll cut the shape right from the middle of this box. Okay, so you have 2.5 boxes above, 2.5 boxes below. Does this look like a line of symmetry? Let's see. So if this is my line of symmetry, then well, this half would come on top of this half, so that works fine. This half should come on, so that's missing, right? This shading should be over here, and this shading should be over here, which is also missing, right? So we can only shade one small square. If this is my line of symmetry, the horizontal one, I'll have to shade 2. I'll have to shade 2 squares, this square and this square. So this is definitely not my line of symmetry. I'll give up on the whole thing, and I'll try another line of symmetry. Okay. I don't know. I don't even know which one is it. So I'm working it out with you. So I worked out the horizontal one first. It looks like this is not line of symmetry. I'll try the vertical one. So this thing would come off on top of each other. This one, if I were to consider this should have a This shape should have a shading over here, which is not. This thing should have a shading over here, which is not. So obviously this is also not the line of symmetry, okay? Because, well, right, so this also doesn't work. Let's try this. So the horizontal and the vertical failed. So I'll try the diagonal one. If I have to run a line diagonally right through it, this would come on top of it. So this works. This would come over here, right? So this works too. This should have a shape, the shading over here. And we could shade one small skirt. So if I were to shade this looks like a perfectly symmetrical shape, which means this is my line of symmetry. Okay, so diagonal one is my line of symmetry. You don't have to draw the line of symmetry because you're not required to. Okay, you can take it off if you want to. Even if it's drawn, it doesn't matter. So, but my line of symmetry is the diagonal one. So you only require to show the shading, not the line of symmetry, right? Okay, let's move on to next. So here's a regular polygon. If you notice, what do we know about regular polygons? We know that they have same sides and same angles. So all of the internal angles that you see, they're all equal. Okay, so this angle is equal to this angle, which is equal to this angle, which is equal to this angle. All these angles are equal, and also the length of each side is also equal, right? And we want to find out, complete the description of the rotational symmetry. I want to find out what's the rotational symmetry of this polygon. This polygon has a rotational symmetry of order. So what is the order of the rotational symmetry of this polygon, right? So as a student, how would I think about this? Well, when I think about rotational symmetry, I would say, well, how many times, if I were to start from here, let's say, if I were to start from here, and let's say here's where I am starting from. If I rotate this, if I give it a 360 turn, right, and I end up and I come back where I started from, how many times will this shape come on top of each other? Which means this shape would superimpose each other, right? So think about this for a while. If I were to take, let's say I'm starting from here. If I take this thing over to this side, then this shading area will be moved to here, move on to here. This area will move on to here. And this shaded area will move on here. Okay? And this shaded area will move on here, which means that making it a turn over here won't give me any result, because if the shaded areas are over here, that's not the same image as the original one, right? So I'll have to give it one more turn. And if I were to give it one more turn, now the shaded area which was over here would now become over there. The shaded area which was now over here would now come exactly superimposed on the shaded area. And this shaded area which was previously over here would end up being here. So that's how I will get a exact image of the actual image, which means after every other turn. Okay, so this is the first turn, but on the second turn, so I got it once, right? And then if I give it one more turn, right? And if I give it one more turn after every other turn, so if I were to bring my handle, let's say this is the handle by which I'm, rotating this thing. That's how I think of it. And then if I give it one more turn, so nothing would happen on this turn, but if I give it one more turn, come back here, thrice I will get the same thing. On a complete round trip, I will get the same image 3 times. So the rotational symmetry is of order 3. Yep, that's how I kind of process the rotational symmetry questions in my head. Okay, I hope you get that. Right, question number 5. Simplify 2a minus 3b plus 4b minus 5a. So you put the like terms together, right? So this 2a and 5a are the like terms, so I'll put them together. 2a minus 5a, and I'll put the other like terms together. So the like terms are negative 3b plus 4b, and if I'll solve them, 2a minus 5a would be negative 3a. Negative 3b plus 4b would be, I think, plus b. So you can also write it this way, negative 3a plus b. You can also write it b minus 3a. It's the same thing. Right. Next, expand. So by expanding 5 times 3x minus 2. So This is pretty simple. You take the and distribute it to every other term. So every term actually, not every other term. Every term. So 5 times 3x would be 15x minus 5 times 2 is 10. So 15x minus 10 is your answer for this one. I don't think it was that difficult. Let's move on. This sounds like something. A table shows the time spent on homework and the number of errors made for STEM students in a class. Okay, the time is in minutes. If you spend 79 minutes doing a homework, okay, so one student spent 79 minutes doing the homework and he made 5 errors. The other student spent 92 minutes doing a question and he did 1 error. Okay, if you spend 91 minutes, there were 3 errors. 85 minutes, 3 errors. 82 minutes, 5 errors, and so on. I see. Right. Okay, so here's a table. Acha, okay. Complete the scatter diagram. First 6 points have been plotted for you. Yeah, I was hoping that. Not all of the points are plotted. So the shaded ones are plotted, and we have to plot the rest. So 60, if you spend 60 minutes, the errors made will be 9 errors. So 60 minutes would be over here. I'm kind of meticulous about this, so I'll do it. I normally do it this way. I run a line through it, and where the lines intersect, I put my cross. That's kind of my way of doing it. 60 minutes and 9 errors. So here's 9. Yeah, so here's mine. I'll put a cross over here and I take off these lines. Yeah, that's kind of I do it. Acha, 65 and 7. So we're 65 minutes and 7 errors. So I'll run a line through 65. And there is 65. And how many errors? If you spend 65 minutes, you do 7 errors. So 65 minutes and 7 errors. Where's the other line? So this should be over here. I hope I made it right. Yeah. Acha ji. 63 minutes and 8. So 63 would be okay. This is you'll have to be careful about this. So 60, 61, 62, 63, 64, and 65, which means every box means 1 minute on x-axis. That's settled. 60, how many minutes? I have to keep going. 63 minutes and 8 errors. Okay, so 63 would be 60, 61, 62. This is 63. Okay, so 63 minutes and I forgot again. 63 minutes and 8 errors. Okay, so did we do this already? Okay. 63 minutes, I'll run line through 63 and 8 errors. Yeah, sorry. I had to keep looking back at it. 8 errors. Here are your 8 errors. Next, 70 minutes and 7 errors. Okay, 70 minutes. Where's 70 minutes? 70 minutes and 7 errors. So my cross should be over here. Yeah. Okay. My cross should be over here. Okay, I'll take off these. Okay, so what pattern do you see? I mean, I'm not talking about the question right now. We're done solving this bit of the question at least. But what trend do you see? Let's try to interpret this. During the paper, do not spend a lot of time doing it. I would still recommend whenever you get a graph or anything like that, take a moment after you're if you're done solving any part, try to take a bird eye view of the question, what the question is trying to say, or what is being depicted over here. Okay, so what I see, I don't know what the question is about, right, yet, because I only plotted the points right now. But what I see is there is a downward trend. Right. What I see is the more time you spend doing the homework, the less errors you make. Because you spend less time doing it, the more errors, right? But if you spend more and more time, the errors reduce. I mean, there's one point, if you spend 95 minutes, the errors, 0 errors, right? So that kind of makes sense, right? It's, I mean, the more time you spend doing something, the more effort you put into something, the more likely it is to, the more likely it is to be better, right? Okay, next part B. We're done with part A. On the scatter diagram, draw a line of best fit. Well, what do you even mean by a line of best fit? Which means a line that, as much as it can, as accurately as it can, depicts the trend. So I think, and yours could be different, that's totally fine. But it tells me that that should be close to as many points as possible. So I think by I, my line should look like this. Okay. This is my line of best fit. You can expand. Yep. Okay. Yours could look different, slightly different from it. That's totally fine. Okay, because you have to draw it by eye. You don't have to draw, you're not in A level, so you don't have to draw exact line with the coordinates and measures. In O levels, you only have to draw the line of best fit by eye. Okay? So in other words, whatever you see fit. Make sure that it shows a downward trend. That's all. Next, so is it close to as many lines as possible? I think it is, right? It is close to, although it should have been a bit like this. I feel like because it's not as close to these points. I feel like these points are missing out a bit. These points are sort of missing out a bit. So I think the line should be a little, a little, yeah, something like this. Now it's more closer to a lot of points, I guess. Yeah. The previous one is fine too. Another of the students in the class made 6 errors. Use your line of best fit to estimate this student spent the time this student spent on the homework task. So let's see. If this student made 6 errors, right? Now this trend tells us that, okay, the more time you spend doing your homework, the less is the number of errors, right? So if you made 6 errors, if somebody made 6 errors, let's say, according to my line of best fit, now yours could be different, and that's totally fine. How many errors? Well, I think the number of errors are, and this is according to my prediction, according to my line of best fit, the number of the time spent 71, 72, I think 73 minutes. Yours could be different again. Okay, and this one normally we have a range of values to pick from. All right. Okay, let's move on to the next one. All right. How many minutes? So I think 73 minutes. We already worked it out. Yes, 73 minutes. Okay. This was question. Let me real quick confirm from the marking scheme. Question number 6, 5, 6. Yeah. They don't really give you value. It's just like according to their line of best fit. So it depends on whatever your line of best fit is. Right. Next, question number 7. By writing each number correct to one significant figure, calculate an estimate for the value. So we're looking for the estimate, and we're looking for one significant figure. Okay, so the first job would be to convert everything into one significant figure. Now, it's a very, very common mistake to write an is equal to over here. Okay? Do not do this because we're doing an estimation. We're looking for the approximate value. So either do not write anything as for the equality, or if you have to write something, do this. This tells you that, okay, whatever I'm about to do is an approximation of what is already written over here. Okay, so 3.1, if you round it to one sig fig, that would be just 3. Multiplied by 26.7, if you round it to one sig fig, I think that would be 30, because 30 is one sig fig, right? Divided by 6.9, if you round it to one sig fig, that will be just 7. If I make it 7.2, there will be 2 sig figs, just to let you know. minus 2.3. If you round it to one sig fig, there will be just 2. Okay. Again, 3 times 30. I will not multiply right away. I'll keep it like this. 7 minus 2 is 5. Okay, now I will do the cancellation because I'm supposed to do the cancellation, right? So 5 times 1, should I do the cancellation in the next step? Yeah. Okay. So 5 times 1, and I think 5, 6 are 30. And 6 times 3 is 18. What? So, yep, your overall answer is 18. 6 times 3 is 18. And that is my answer. Okay. Um, 337 and 2. Yeah, same. Right. These are the first 4 terms of a sequence. So we're given a sequence, right? If you notice, I mean, before moving, even as a student, if I am doing this paper, right? If I see the sequence, I will spend the next minute figuring out what is the sequence. So going from here to here, I think this is plus 6, right? Going from here to here, 8, 9, 10, 11, 12, 13, 14. I think this is also plus 6, right? So this is also plus 6. Definitely an arithmetic sequence. Arithmetic sequence. All right, find the next number in the sequence. So of course, I think it should be pretty simple because if every other term is if you're getting the every next term by an addition of 6, you might as well do another plus 6 and that'll be 26. That's peanuts. Yeah, that's really simple. 26. Next, find an expression in terms of n for the nth term of the sequence. So how do you find out the nth term? I think for arithmetic sequence, we know the nth term is equal to a1, the first term, plus n minus 1 times d. Okay? And we only put the values for a1 and d. Okay, we don't put anything for n. We keep it as it is. So d is the common difference. We know that d is equal to 6 because this is the common difference. This is what every term is. You add 6 and you get the next term, right? So an is equal to, what's the first term? I think a1 is equal to, should I write this over here? D is equal to 6. a1 is equal to 2. We should write it here. So a1 is 2 plus n minus 1 times 6, right? Let's say 2 plus, if you multiply 6 by n and 1, so it'll be 6n minus 1, right? So, yeah. 2 minus 1 is just 1, so that you'll get, oh, what? You multiply 6 by 1, you get a 6. I'm sorry. 2 minus 6 is minus 4, so you'll get altogether 6n minus 4, and that is your an, the general term, the so-called general term, right? An is equal to 6n minus 4. Even if you write 6n minus 4, that's also fine, right? I hope there's no confusion so far. Let's move on. Ooh, transformations. I can already tell this is transformations because I see a small figure and a bigger figure. Anyways, so I see a smaller triangle and I see a bigger triangle. Okay. Describe fully the single transformation. So it is a single transformation. So that maps triangle A onto triangle B. Okay, so we applied just one transformation and that turned triangle A into triangle B. What do you think that magic transformation is? Obviously, it's enlargement, right? We took a triangle and we enlarged it. So how do we describe a transformation? I think you might have learned, your teacher might have taught you. When we say describe, and we can already tell it's enlargement, by how many parameters and how many ways, or how do we fully describe an enlargement? Well, you need 3 things. You need center of enlargement, COE. I'll just write it COE, center of enlargement. I hope it's fine. And we'll write the scale factor. Okay, that's how we fully describe a transformation. So first of all, you have to tell that it's an enlargement. Okay. You can just start off by writing it's a center of enlargement of a scale factor without telling that it is an enlargement. The first thing to know that it is enlargement. Okay, so we need to find out the center of enlargement and the scale factor. Scale factor is simple. This is 2, right? This side. Take the corresponding sides. You can take this side. Okay, so this side was initially it was 1, and then you expanded it, you enlarged it, you stretched it, and it turned into 3. Right? This is the corresponding side. The scale factor, of course, is 3. If you want to do the proper math on this, you can do, well, this is 1, this is 3, so scale factor is equal to, this is the image, by the way, and this is the object. Well, how do I know? How do I know which one is image, which one is the object? I can tell from the question. The question says, if you really, really read the question, it says that maps triangle A onto triangle B. So which means this is the angle you started with. So this was the object, right? And it was mapped onto triangle B. So this will be the image, right? The scale factor is equal to, and you take any corresponding side of the image and you divide that by the object. Sorry for my bad handwriting. For the image, it will be 3 for, I'm picking up this length, and for the object, the actual length was for the object was 1, but when we stretched it to make it 3, the scale factor is definitely 3. Okay. You don't have to write SF, you have to write it fully. Scale factor. Scale factor is equal to 3. You just worked it out. Center of enlargement. How do we find out the center of enlargement? So you connect the corners, you connect the vertices, and see where do these vertices meet. Where do the lines connecting the vertices meet? What do I mean by that? Well, this is what I mean by that. This vertex is corresponding to this vertex, right? This vertex is corresponding to this vertex, and this vertex is a different color for this. This vertex corresponds to this vertex, right? So I'm going to join them. So I'm going to join them, and I'm going to stretch it even further than joining. I'll stretch it a bit further. Okay. Now I'll join this one by this one, and I'll stretch it even further. And I'll take 2 are fine, but I'll just to be on the safe side, I'll take the third one too. I'm going to join the vertices, and let's see what am I getting. So where do these lines are having a meetup, are having a meetup party? These lines are having a meetup party over here. So this is where they meetup scenes. That's what they call in Karachi. I don't know. Meetup scenes. So this is where they meet. Okay. So this where the point where all of the lines connecting the corresponding vertices meet. This is the center of enlargement. Center of enlargement. Okay. And center of enlargement, of course, it's 3, 4. So this thingy is 3, 4. So I will write over here down there. Center of enlargement, I should make it proper. Center of enlargement is equal to, is what? 3, 4, right? Yeah, so I'm exceptionally good at forgetting. 3, 4. Right? So that's it. That's all. That's all you need to do while fully describing the enlargement. Okay? Because we knew it's enlargement, right? It's a blind can tell it's an enlargement. Next, triangle A is mapped onto triangle C by the translation. Translation just means walking. Okay. Translation just means walking, right? Nothing changes. You just walk from. So you walk -3 means, well, this means left. This tells you whether something is left, walking left or right, and this means up, down. Okay. So yeah. So -3 means, of course, it's negative, which means we're walking to the left. So 3 units left. 3 units left, and 2 is positive 2, which means 2 units. If it's positive, which means you go up. If it's negative, you go down. Okay, so 2 units up. 3 left, 2 up. 3 left, 2 up. It's a note to self because I keep forgetting. So 3 left, 2 up. You take every corner, right? Should I take it off? Should I take it, like, these lines off? I feel like they're bothering me a bit. Okay, I'll keep them if you would say so. 3 left, 2 up. So I'll take this point. I'll take every single point and I will move it 3 left, 2 up. Okay, so I'll take this point. Should I pick up a different color? I should pick up a different color. Yeah. So take this point. 1, 2, 3. This is 3 to the left. Okay. And this side is left. This is right. It's 3 left, 2 up. 1 up, 2 up. So this is my point. Yeah. Right. I'll take this point. 3 left, 2 up. 1, 2, 3. I'll take it off. 1, 2. So here's the other one. All right. I'll talk about this one. So 3 left, 1, 2, 3, 2 up. Yeah, here we go. So here's my new triangle. Okay. You might have learned a different way of drawing it, and that's fine. I have my own silly way of doing things. So yeah, but this works, right? Yeah. So this is my triangle C. Okay, you're allowed to make it as much of a mess on it as possible. That's totally fine. Say it. So yeah, we just drew a triangle on it, and yeah, that's all we were supposed to do. And make sure to label it. Draw the triangle C. So we're supposed to draw a triangle C. Don't just draw the triangle, but also label it. Just like this triangle is labeled as triangle A, this triangle is labeled as triangle B. So make sure to label this your triangle, just to stay consistent with what everybody is doing. Draw the triangle C. Right, next question. Solve the simultaneous equations. Show you're working. So I'm taught, as a student, I'm taught 2 ways of doing my simultaneous equations. One is the elimination, one is the substitution. You're allowed to pick. I'll actually show you both, but you're allowed to pick and choose. Okay? You can pick and choose any method. One of it is you can do it by elimination. You can do it by substitution. It's totally up to you. I'll do it by elimination first because I find it easier. Elimination, and the other one is substitute. You don't have to do both. You only have to pick one. Okay, either elimination or substitution. Right. So in elimination, well, I will eliminate all the enemies of. I will eliminate a variable. Okay. So think about this for a while. Which variable sounds like an easy target? Think about it, right? We have 2 equations, 3a plus b equals -4 and 2a plus 3b equals 9. Which variable sounds like an easy target? I think if I somehow multiply the whole thing by -3. So what I will do is I will get a -3b here, which I can cancel out with +3b, right? So that's a sort of a clever way of dealing with elimination, right? So I'll call this equation 1. I'll call this equation 2. I'll take equation 1 and I'll multiply everything in equation 1 by -3. Okay, so that I can I'll multiply this by -3, and I'll also multiply this dude over here by -3. What am I gonna get? I think I'm gonna get -3 times 3 would be -9a, -3b. Aha, that's a target. That's what I wanted. -3b. If you don't understand, you'll get in a while. Okay, I just made this guy. I just framed this guy. You might have seen the serial killer movies where a guy, kills someone and frames someone else for the murder. Yeah, sorry, it got dark here. 4 times 3 is -4 times -3 is 12. I'll take the other equation and I'll add the 2 equations. So the other equation is 2a plus 3b equals 9. I'll add the both equations. So by virtue of adding them together, I can very cleverly cancel them out. Okay, so Negative 9 plus 2 is just negative 7a. This will just cancel out. So 0 plus 12 plus 9, I think it's 21, if I'm not wrong. Yeah, it should be 21. Right. So 21. Negative 7a equals 21. If I divide by negative 7 on both sides, I'm going to get 21 divided by negative 7. I think I'm going to get negative 3. Okay. So you got the value of a. I think once you get the value of one variable, it becomes really easy. Now it's a matter of choice. You can either put it in this equation or this equation to get the value of other variable. I'll put the first equation. So 3a plus b equals negative 4. Put a is equal to negative 3 in there. So instead of a, I'm going to get a negative 3. I'm going to put a negative 3 plus b equals negative 4. So 3 times negative 3, I think it will be negative 9 plus b equals negative 4. b equals negative 4 plus 9. And I'm going to get what? What is 9? Negative 4 plus 9? I think it's 5. So I got my values of a and b. I got a equals negative 3, b equals 5. Right? But this is not the only way. There are other ways of doing the same question as well. Okay, I'll show you. People have got preference. Okay, some people prefer substitution, some people prefer elimination. I think you can already tell what is my preference because I did elimination first. So elimination is kind of my preference, but it's totally up to you. You can pick any method you want. It doesn't really matter as long as you're getting the right answer. So in substitution, what we do is we pick up a variable and we isolate a variable. So I'll pick the first equation and isolate 3a plus b equals negative 4. I will isolate b. So if I were to isolate b, this is going to become negative 4 minus 3a, right? I'll put the value of b in this equation, the second one, right? It's just an interplay of equations and nothing else. Right, so 2a plus 3 times, instead of b, I'm going to put negative 4 and negative 3a, negative 4, negative 3a. It feels like I've made it a lot messier. But anyways, that's how substitution is supposed to look like. So 2a plus 3 times negative 4, I think it's negative 12, right? Negative 12, negative 9a equals 9. Okay. So, okay. 2a minus 9a, I think it's negative 7a. Should I do it properly? 2a minus 9a. If I were to send this 12 over to the other side of the equation, I am going to get 9 plus 12. So this will be negative 7a. 9 plus 12 is 21. A equals, you might be getting flashbacks of this thingy over here because, yeah, it's the same thing. It's just done differently. So 21 over negative 7, which is just negative 3. So we got the value of a to be negative 3. I think the other step is pretty common. It's the same as this one. So the next step is the same as this one. So I'll just copy this step. The next step is the same. Yeah, it's the same thing. You take the value of a and you put it in the other equation to get the value of b. That's how simple it is. Okay, getting the value of the first variable is kind of tricky. The second one is okay. Okay, I might be hiding some of your solutions, but that's fine. Right. So we already did 10 questions. You can take a coffee break if you want. Point A, 2, 4 is joined to point B. So, I mean, the first thing I do whenever I read something like this, I don't like reading these abstract things. I would rather draw them just to see how it's going, right? So, point A is 2, 4. Point B is 5, negative 2. Yeah, that makes sense now. Are joined by a straight line. Of course, this is a straight. Find the coordinates of the midpoint. So I need to find the coordinates of this midpoint over here. Not a problem. Pretty straightforward. We know the midpoint formula, which is x1 plus x2 by 2 y1 plus y2 divided by 2. And this is, by the way, x1, y1, this is x2, this is y2. And nothing is simpler than this in the entire world. 2 plus 5 divided by 2, y1 plus y2 would be 4. 4 minus 2 divided by 2. Now you might be wondering, where did this minus come from? Well, 4 plus minus 2. Okay, 5 plus 2 is 7 divided by 2, comma. 4 minus 2 is what? 2 divided by 2, which is just 1, right? So 7 by 2, comma 1. These are my coordinates of the midpoint. So I'm already given a template. All you have to do is put the first coordinate 7 by 2 in here. You can also write it as 3.5, that's fine. And 1, right? Easy peasy. Find the gradient of the line AB. So just like we have a formula for midpoint, we also have a formula for gradient. Is just plugging in the values and nothing else. This is pretty simple. So gradient, we know that y2 minus y1 divided by x2 minus x1. I've already labeled x1, y1, x2, y2 for you. All you have to do is grab those values from the question and put them in there. Plug them in the equation. So y2 is -2, y1 is -4, x2 is 5, x1 is 2. So I'm going to get -4, -2 is -6. 5 minus 2 is, I think, 3. So I think the gradient is -2. Okay. I hope there's no confusion about that. Right? This is pretty straightforward, I think. y2 minus y1. Yeah. Right. Next. So yeah, I have to put in the values, put in the value of the gradient over here. Next, write 0.000257 in the standard form. So really easy to do the standard form is, this is my reference point. This is between 2 and 5 is where I want my decimal to be. So I'll take forward jumps. Remember, whenever there's forward jumps, whenever you're making your decimal point, make a forward jump, it will be 10 to the power negative times the number of jumps. Okay, and whenever you allow your decimal to take a backward jump, I normally write it like this: FWD jump, forward jump, and backward jump. Then 10 to the power plus times plus number of jumps. Okay, so over here, this is my decimal. And 1, 2, 3, 4. I took 4 jumps forward, right? So this will be, my decimal point is now between 2.57. 10 to the power, so how many jumps did you make? You made 4 jumps, so you write 4 here. Now, since these was forward jumps, so I'll put a negative over here. Okay. Next, work out 2 times 10 to the power 4 divided by 4 times 10 to the power -5, let's say. Well, it's simply laws of indices, right? So I'll just cancel out 2 to 10 to the power 4 divided by 4 multiplied by 10 to the power -5. So for these two guys over there, I'll just apply cancellation. And for these guys, I'll apply laws of indices. So 2 times 1 is 2, 2 times 2 is 4. I'll be left with 1 by 2 times 10 to the power. Now, if you remember from the laws of indices, it tells you that if you have a to the power m divided by a to the power n, in short, the bases are the same and you have different powers. You can write them as a single base and subtract the powers. So that's what I'll do here. I have the same base as 10, and now I'll subtract the powers. 4 minus, be sure that you'll have to double subtract. 1 over 2 is just 0.5, right? So 0.5 times 10 to the power, this will be 9, right? 4 plus 5. So 0.5 times 4 plus 5 is 9, right? Now, it feels like we're done here, but we're not. Okay. Why? Because I want my answer in standard form, right? And in standard form, the decimal point should be after the first non-zero number, right? So I'll take a forward jump. And again, if you do a forward jump, 10 to the power, you subtract the number of jumps. So 5 times 10 to the power, if I were to do the forward jump, the decimal point will now be ahead of 5, right? And this will lead me to do a -1. Why did I do a -1 over here? Because I took a forward jump. Okay, so 5 multiplied by 10 to the power, 9 minus 1 is 8. This is my answer. Okay. Yeah, I know. It feels a bit weird, but that's how it is. Question 13. Work out 2 1 over 5 divided by 3 over 4. So I am taught, first of all, I have to convert this into normal fraction. This is mixed fraction. Okay. So I'm sure you know how to convert this into a regular fraction. You multiply 2 with 5, you get a 10, and then you multiply. And then after you're done multiplying, you do an addition. Okay. So 5 times 2 is 10. 10 plus 1 is 11. So this will be 11 divided by 5. I cannot perform this division right away. I'll have to first convert this into multiplication. So what's the price? I mean, I can't just write division as multiplication, right? I have to pay the price for it. What's the price we pay for converting this division into multiplication? I'm sure you must have heard about it ever since grade 3 or 4. You reciprocal the fraction right next to it. So instead of 3 over 4, it's going to become 4 divided by 3. Now it's really simple now. 11 times 4 is 44. 5 threes are 15. Okay. Now we're not done here. Give your answer in the mixed number. We have to reconvert it into a mixed fraction. So it's really simple. You do 15. This is the divisor and this is the dividend. So 15 outside, 44 inside. 15, I think. Oh, with 15 times 3 is 45. We barely missed it. It's 44. So I'll have to take 2 anyway. 2 30. I left with 14, right? So this is my quotient, this is my divisor, and this is my remainder. Okay. If you don't know how to, I'm doing it for beginners, right? If you already know how to, you can just skip ahead. This is remainder. To convert this into a fraction form, QR by D. Okay. So quotient is what? 2. I'll put a 2 here. Our remainder is 14. I'll put 14 over here. And divisor is 15. So 2, 14 divided by 15. Okay. This is my answer. Right. Question number 14. Write 360 as a product of its prime factors. How would you do that? Well, we simply follow prime factorization, don't we? 360, we make our beloved table. This is something O-level students do, and IGCSE students too. They do it initially, like when they're entering into, and they just start in O1, I think. So they find it fun. Yeah, whoever I've talked to, they find it quite fun. 2, and this will be 180, and 2, I think this would be 90, 2 again, 45. Now the next prime number, I'll see if it's after 2, the next prime number is 3. So I'll try 3. 3 times 15 is 45. 3 times 5 is 15. So, and 5 times 1 is 15. So how would you write it as a product of its prime factors? Well, these are all the prime factors. Okay. You simply write them in product form. So 2 times 2 times 2 times 3 times 3 times 5. Okay, right. Find the smallest positive number n such that 360n is a cube number. You can also write it this way. 2 cubed times, we have 2 of the 3's, so 3 squared times 5. Right. If I want to make it a cube number, think about it. I want all of my factors to be in triplets. Okay, this is a triplet, that's fine. But this is not a triplet, this is not a triplet, right? So what's missing? I think there's a 3 missing, and there are 2 5s missing, right? So I'll write 360n is equal to 2 cubed multiplied by 3 squared times 5. What's missing? There's a 3 missing, and there's a 5 squared missing. Okay, so if you notice, this yellow bit is just 360, right? Now, if I have written 360n, then whatever, I mean, perhaps not the best highlighter for this color, n, five, what am I doing? Okay, 5 squared. So this would be this would make it a perfect cube. Okay. If I were to multiply these factors by this number, notice that this 3 would make this a perfect triplet, and this 5 squared coupled with this 5 would make a perfect triplet. So all of them will be in triplets, and that's how it will be a perfect cube. Okay, so my n is equal to 3 times 5 squared. Okay, which is what? I think solve it first. So n is equal to 3 times 5 squared. You have to find the smallest positive integer, right? So you have to write it as in the form of integer. 3 times 5 squared is what? 25. 25 times 3 is 75. So 75 is my answer for this bit. Okay, so next question number 15. A sector of a circle with an angle of 60 degrees has arc length 4 pi centimeters. Find the area of a sector, give your answer as simply as possible in terms of pi. I like my things drawn. Okay, so whenever I get a geometry question, the first thing I do is I'll try to draw it. It doesn't have to be accurate. It doesn't have to be an accurate drawing, but at least it should make sense. Okay, it should give me a sense of what's going on in the question. So first of all, there is a sector of a circle, right? Sector is something that's coming out of a circle like a pizza slice. Let's say the whole circle is a pizza, then this is a pizza slice, a rather big one. With an angle of 60 degrees, so here is my angle of 60 degrees. Okay, with an arc length of 4 pi centimeters. So this thing over here, this arc length is, I should make it a little, this arc length over here is 4 pi. Should I use a better color? I'm just too worried about the aesthetics sometimes. This arc length is 4 pi centimeters. 4 pi centimeters. 4 pi centimeters. Right, find the area of a sector. I don't know what's the radius of this circle. So the first thing I might have to do is to find out the radius. But let's look at the formulae first. What are the formulae? So we're given two things. The first thing we're given is the arc length. Okay, they're talking about two things. The first thing that is being talked about is the arc length. And the second thing that is talked about is the area of a sector. So I should know the formulae of the area of a sector and the arc length. Okay, so let me put up the formula area of sector. Actually, arc length for the total circle is 2 pi r. Okay, if the angle is 360 degrees, like for the 360 degree means the arc length of the total circle is 2 pi r. If I want to find out the arc length at a specific angle, I'll have to divide that angle by theta divided by 360 degrees. Okay. If your theta is 360 degrees, which means if your theta is, let's say, the whole circle, so it'll be 360 by 360 multiplied by 2 pi r, which will just be 2 pi r, which means we're talking about the full circle. But whenever it's a specific angle, you put that angle in there and you divide that by 360, and then you multiply that by 2 pi r. Area of a sector, we also know that the formula for the area of a sector would be, again, the ratio of the angle, so theta divided by 360 multiplied by pi r square. Pi r square is the radius, pi r square again This is the arc length of the complete circle. This is the area of the complete circle. Okay. This is the scale factor. I mean, the scale factor means we're talking about the bit, the part. Okay. Which part? 60 out of 360. I hope it makes sense. Okay. So the first thing we'll do is, I don't know the radius. Okay. I only know that this angle is 360 degrees and that's all. But I need to find out the area of a sector, and the formula for the area of a sector tells me that I need to find out the radius first. So that's what we will do first. We know that the arc length is 4 pi. So from the formula, we know that arc length, we've put the formula as well, there is theta divided by 360 multiplied by 2 pi r. Arc length, we already know, is 4 pi divided by theta is 60 degrees. So I'll put 60 divided by 360 multiplied by 2 pi r. Now we carefully do the solving. Do not do any cancellation right now unless before you have isolated r. So if I were to isolate r, I would, if I want to isolate r, I'll keep r where it is, and 360 is being divided. It's going to go to the other side. It will be multiplied. Why am I changing pens? 4 pi multiplied by 360, because 360 is being divided, and 60 and 2 pi, 60 multiplied by 2 pi will come in the denominator, and you'll be left with r. I hope you know about this. This is very simple. Right, next, you do the cancellation. So normally what I do is I do the cancellation in the next step. Okay, it always helps. If you do cancellation then and there, then it confuses the examiner. If I'm the examiner, I would be very confused. I'll still give you the marks for the right answer, but again, I would be confused. Okay, so 6, you'll cancel out zeros. 6 times 1 is 60. 6 times 6 is 360, right? Then I'll cancel out pi with pi. Then I'll cancel out 2. So I'm just left with 2 and 6. So 2 times 6 is 12. So my radius is equal to 12. That's the intermediate working that we worked. This is called the intermediate working. And so we found out the radius, right? Now I know the radius. The radius is 12. Now I can find out the area of this sector. Basically, I'm talking about this area over here. This is the area I'm talking about. If I were to highlight it, it's going to take a while. I'll still try. Yeah. I should really go back to kindergarten to learn the shading. Anyways, now the next thing we'll do is area of sector. So what's the area of a sector? Area of a sector is theta divided by 360 multiplied by pi r squared. And we know everything. We'll just put in the values. 60, theta is 60, that's the angle, divided by 360, and you multiply that by pi, and radius is 12. So we have radius squared, right? So I'll do 12 multiplied by 12. Okay? Because remember, this is a non-calc paper. So I'll simplify the work for myself as much as possible so that I can do the cancellation, right? Okay, in the next step, we'll do the cancellation. Let's see. Here we go. I will cancel out 0 with a 0. 6 times 1 is 6. 6 times 6 is 36. Again, 6 times 1 is 6 times 1 is 6. 6 times 2 is 12. I think we're done. So no, we don't have to simplify this pi, because if you go back to the question, it says in terms of pi. In terms of pi means pi remains intact. There should be a pi present in your answer. Okay, so I'm not going to touch pi. 6 times, like, what did I just write? 12? No, 6 times 2 is 12. Sorry. 6 times 2 is 12. So what am I left with? I think I am left with 2 and 12. So that's what I'll multiply. And pi. So 2 times 12 is 12 times 2 is 24. So area of sector is equal to 24 pi. So 24 pi centimeter squared. I hope it wasn't that bad. Okay. The fact that I exceeded my space is because I wrote the formulas twice and everything. So that's why. I mean, I can still do it. Let's not. Let's just do it. Oh God, I'm so indecisive. I want to make it less messy as possible. Yeah, I heard those helps. This is separate working. Anyways, right. So we're done here with question number 15. Question number 16. Express as a single matrix. This should be simple. First of all, you do the multiplication. So you multiply 2 with everything that's inside in the first matrix. Okay, so 3 times 2, 3 multiplied by 2. Over here, this is 2 multiplied by 2 minus 1 multiplied by 2 and 4 multiplied by 2. And you subtract this matrix by 1, -2, 3, and 5, which will turn into 3 times 2 is 6, 4, -2, and 8, minus 1, -2, 3, and 5. I think I should get, from here, I should get, so you subtract the corresponding entries. This corresponds to this entry. This thing corresponds to this entry. This entry corresponds to this entry. I hope you know about this. That's not so bad. So 6 minus 1, I'll do 6 minus 1. And 4, so there are 2 subtractions. Here's a subtraction and here's another negative. So you'll do 6 plus 2. I hope it wasn't too direct. -2, -3, and 8 minus 5. And I'll be left with 6 minus 1 is 5. 4 plus 2 is 6. -2, -3 is -8, -5. Sorry. And 8 minus 5 is 3. So 5 minus 5, 6 and 3. So 5 minus 5, 6 and 3. Right? That is my answer. This was simple. Okay. Next, matrix A equals 4, K, 2, and 1. The determinant of AA is 10. Find the value of K. So what do we know about determinant? We know that if a determinant is A, let's say A, B, C, D, A, B, C, D, then determinant is equal to AD minus BC, which means you multiply these 2 elements, right? And then you do a subtraction and then you multiply these 2 elements. Okay, AD minus BC. So let's calculate the determinant. We already know the determinant, right? So for 2K1, the determinant is equal to 10. If I were to calculate the determinant, I'll get 4 times 1 would be 4. So 4 times 1 minus 2 times K is equal to 10. If I work it out, 4 minus 2K is equal to 10. And well, I can isolate -2K. So -2K is equal to 10 minus 4. 10 minus 4 is what? I think 6 divided by -2. I think I'm going to get -3. Okay, so K is equal to -3. This is your answer. Can I did it fast because you should be able to do this by yourself, and this is just algebra, nothing more than that. Find A inverse. So what's the formula for A inverse? We know that A inverse, the formula for A inverse is equal to 1 over determinant of A multiplied by adjoint of A. Adjoint of A. This is a very common mistake. People read it as adjoint. This is the word. But whenever you have D and J together, the D is silent. Okay, so for example, the word adjective, people pronounce it as adjective. And the word adjourn, this is normally used in courts, right? So for example, when a judge wants to say, well, okay, settle everything, he says adjourn the hearing is done. So that's wrap up the hearing. Adjourn, adjacent, that's another word. In all of them, the D is silent. Okay. The D is silent. You don't pronounce the D. Okay. Adjoined, adjective, adjourn, adjacent. Do not again say adjoint. It's adjoint. Right. So inverse is equal to 1 over determinant of A. We know the determinant of A. All we have to do is find out the adjoint of A. So what's the adjoint? What's the matrix A first of all? We know the value of K is -3. So I'll write the matrix A first. Matrix A was actually 4, 2. I'm borrowing this matrix from here. 4, 2, 1. And in place of K, I'm going to put -3 because we just worked out the value of K. Okay. Now, how do we calculate the adjoint? Adjoint is pretty simple. Uh, this is called the right diagonal. This is called the left diagonal. This is, I just gave them names by myself. So anyways, this diagonal, you change the sides. And for this diagonal, you change the, for this diagonal, you swap the values. And for this diagonal, you change the signs. Okay. So for the first diagonal, I'm going to swap the values. This is going to be 1, 4. And if I were to swap the angles, so signs, I'm so sorry. So it becomes -3 becomes +3 and 2 becomes -2. So that's my adjoint. Okay. I'm telling you, this is a pretty simple adjoint. When you eventually land in AS or A2, and when you have a 3 by 3 matrix, calculating adjoint for a 3 by 3 matrix is a job. It's pretty tough. Anyways, so I think I have everything I need. So I have the adjoint of A. I have the determinant of A from the last question, which is actually 10. I'll actually write that. The determinant of A is equal to 10. How do I know it? I know it from the last part because see, they're all questions, they're all parts of the same question. Okay, so you can borrow the values from the previous question. So I think I'm done here. I'll just put A inverse is equal to 1 over the determinant of A multiplied by the adjoint of A, which is 1 over determinant of A is 1 over 10, and adjoint of A is 1, -2, 3, and 4. And if I divide everything by 10, you're going to get 1 by 10, 3 by 10, -2 by 10, and 4 by 10. If you write it like that, that's fine. Even if you don't, I mean, I think it's fine at this point. Yeah. You can write it like that. 1 by 10, 3 by 10, -2 by 10, and 4 by 10. Even if we simplify it, that's also fine. So that is my inverse. It was just for 1 mark only, so we don't have to simplify. Question number 17. The diagram shows the lines y equals 2x plus 1 and x plus y equals 2. I don't even know which line, which is which line, but I can tell that this line has a positive slope because if you can go up on this line. This line has a, the other line has a negative slope. Okay, this line has a negative slope. So this line has a positive slope and this line has a negative slope. If I were to write my equation in the slope-intercept form, you know the slope-intercept form of an equation, right? Y equals mx plus b, right? So if I have to write the first equation, y equals 2x plus 1, I can already tell that this line has, this is the slope. Slope is 2, and this has a positive slope. Okay, so positive slope, this line also has a positive slope, which means that this line equals y equals 2x plus 1. Okay, and if you sort of, the other line should be, if this is the line y equals 2x plus 1, the other line should be x plus y equals to 2. Right. So the region R is defined by these 3 inequalities. Y less than equal to 2x plus 1, x plus y less than equal to 2, and y greater than equal to -2. On the diagram, shade and label the region R. Let's see. All right. This line is drawn. Yes, this line is drawn on the graph. This line is not drawn. So, okay, so I'll first draw y. The line, the associated equation with this is y equals -2. So y is equal to -2 would be this line. Go ahead. This line equals y equals -2. Okay, so let's talk about the shaded region, shall we? So if y is less than or equal to 2x plus 1, we know that less than means the area below, right? Less than equal to means the area below. So I'll shade, this is the area we were talking about. We'll shade this area. Okay. I'll just put temporary these lines, okay, and we'll shade the area once we are finalizing. Once we're done finalizing which area is being shaded. Okay, so for this line, we're talking about the area below this line. X plus y less than equal to 2, which means we're talking about the area below this line. So below would be over here. Okay, and for y greater than equal to 2, greater than equal to means the area up at this line. Okay, so this is the area we're talking about. This line. So which is the area where all of the which is the shared area? I think this is the shared area where all of the shading is meeting. This is the combined shaded area. So I'll take off these and I will do my shading with a highlighter. Because I just realized this is my region. Oh, that was better. That was actually better than the last time. Okay. Yeah. Oh wow. Right. So this is the region we were talking about. So we just shaded this region. Next. The next bit says, so we just shaded the region. The point K, comma, K minus 2 lies, I don't know how to do this, but just let's figure out together. The point K, comma, K minus 2 lies on the region R, where K is an integer. Okay, list the possible values of K. Okay, so we're saying this point is lies in the region R, which means it could be somewhere in this region. So when we say K is an integer, okay, and if something is over here, which means this is the X coordinate, right? So K, which is the X coordinate, and is an integer. So where can we locate K? On the X axis, well, it could be either 0, it could be either 1, it could be either 2. So the possible values of K are K is equal to 1, K is equal 0, 1, and 2. 0, 1, and K is equal to 2. Okay, now correspondingly, let's talk about K minus 2. Okay, so if you do K minus 2, this is the X coordinate I'm talking about. Now we'll work out the Y coordinates from here, and we'll see if the Y coordinates, if the X coordinate and the Y coordinate, if they lie in the region or not. So if X is K, Y is K minus 2, X is equal to K, Y is equal to K minus 2. So if you do K minus 2, this will be 0 minus 2 is equal to negative 2. So the point is 0, comma, negative 2. Does the point 0, comma, negative 2 lie in the region? Let's do this working here and we'll see the points by the very end. K equals 1, so Y would be 1 minus 2 equals negative 1. So the point is 1, comma, negative 1. And if K is equal to 2, then 2 minus 2 is equal to 0. 0, comma, 2, comma, 0 is my point. Do these points lie in the region or not? Let's see. So the first point is 0, comma, 2. 0, comma, 2. 0, comma, negative 2, actually. Yes, this point, what did I do? Okay. This point does lie, 0, comma, negative 2 is this point. This is the point, 0, comma, negative 2. Okay, this point. They've already done so much in it, I don't know which color to use. This is the point, 0, comma, 2. Okay. 1, comma, negative 1 is this point. Yes, it lies in the region. And 2, comma, 0, yes, it lies in the region. Yeah. So all three of these points lie in the region. What are the possible values of K? List the possible values of K. The possible values of K would be 0, 1, and 2. So you could just list them like this: 0, 1, and 2. Yeah, I admit this was a bit different. Okay. So I hope it makes sense. Let's move on to the next one. 50 adults each take part in a quiz. The cumulative frequency diagram shows their scores. So the number 50 is actually the number of the adults, and here we go, is the number of adults, and this is a cumulative frequency graph which shows their scores. Use the diagram to find the estimate of the interquartile range. Well, what do I know about interquartile range? The interquartile range is IQR is actually Q3 minus Q1. In other words, upper quartile minus lower quartile. Okay, so what do we know about the formula of upper quartile and the lower quartile? Well, let's say your data, all of the data is divided into 4 parts. Okay, let's say this is all of your data. And it's divided into 4 parts. 1, 2, 3, a little bit. 1, 2, 3. That's somehow your data is divided into 4 parts. So this bit would be Q1, this is Q2, and this is Q3. Okay, 25% of the data. I mean, this is 0%, this is 25%, this is 50%, this is 75%, and this is 100% of your data, right? So up to 25% is your upper quartile, sorry, lower quartile, and up to 75% is your upper quartile. So you take the value of Q3, you subtract it from Q1, and this is, all of this area is the interquartile range. Okay, so the formula, if this is 1 over 4, this is 2 over 4, this is 3 over 4 times n, but let's say n are all the data points. So Q3 would be 3 over 4n, okay, and n is the number of people who took the quiz, of course, which is 50. So 50 people who took the quiz, 50 adults who, not kids, we're talking about adults here. So 3 over 4n would be 3/4 of 50. If you do the cancellation, 2 times 2 is 4, 2 times 25. 25, 3 is 75. 75 divided by 2 would be, I think, 37.5. Okay, so that's my Q3. 37.5 would be somewhere. This is 35, 36, 37, 38, 39, 40, 35, 36, 37. This should be 37.5. Line through the center should be a bit up, I think. I made it a bit, I think, way too up. It's in the middle. Something like this. Yeah, kind of. Right, so this is 37.5. Okay, let's talk about the lower quartile real quick. Lower quartile would be Q1, which is 1/4 of n. We just saw that, Q1. 1 over 4n, which is 50 divided by 4, and which is, I think, if you do the cancellation, that would be 25 divided by 2, which is 12.5. I did that rather quickly. 12.5 would be where? 10, this is 10, 11, 12, 12.5 would be somewhere over there. Right? Yeah, kind of. Okay, so if I were to drop my line over here, down there, again, okay, it's not as smooth, I think, as I would want it to be. I think it's through the middle. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes means 20, which means each box is 2. So this should be 2, 4, 6, 8, 10, 12, 14, 16. I think this is 17. This is 17. What about this one? Let's see. So this falls at 17, somewhere at 17. And the other one falls at somewhere. 10, 10, 10, 10. I stretch it a bit too ahead. Zoom out a little. You can zoom in on your screen if you want, just to see what's going on over here. Okay, so this is between, I think, 62, 64, 66. I think this is 67, if I'm not wrong. I guess this could be different in your case, and that's totally fine. Right, so this is my Q1 and Q3. I'll do the subtraction, and let's see what will I get. Okay, so you'll do the subtraction. 67 is, remember, this was the upper quartile. This was the upper quartile, and this was the lower quartile. 12.5 was somewhere over here. Should I put my working? Somewhere over here, and I'll make it small just so I can. Okay, so this is my upper quartile, this is my lower quartile. In other words, I'll make this is Q3 and this is Q1. So if you subtract their values, Q3 minus Q1 is 67 minus 67 minus 17, you'll get a 50. So this is the interquartile range. This is the IQR, right? Next. 20% of the adults win a prize for getting a high score in the quiz. Use the diagram to work out the minimum score needed to win the prize. Okay, so think about this for a while. Look at this diagram. Okay, you can see that as the frequency is increasing, the score is also increasing, right? So which adults, 20% of the adults 20% of the adults win a prize for getting the high score, which means we're talking about the last 20 individuals. Okay, 20% of the, well, first of all, we'll calculate what's 20% of 50. Okay, so 20% of 50, I'm sure you know how to do this. 20 divided by 100 multiplied by 50. I think we should get, first of all, I want to figure out how many adults are we talking about. This zero will cancel out with this one, this zero will cancel out with this one, so I'm left with 10 adults. Okay, now if you're talking about the high score, right, which means we're talking about the last 10 adults, because those are the adults which won the prize for the high score, right? So last 10 adults won, last 20% adults, in other words, last 10 adults won the prize. Okay, so from 40 to 50, these are the guys who won the prize. So what was the minimum score needed to win the prize? Well, the minimum score which the 40th individual, the score which the 40th individual scored to win the prize, that's the minimum score. Okay, so if we go down on it, I think it is, there will be 61, 60, sorry, 62, 64, 66, 68, 70, 72, 74. I think 74 is the minimum score needed to 74 is the minimum score which is needed to win the prize, right? Afterwards, anybody who scored more than 74 won the prize. That's the idea. Okay, so all of these above 74 are all prize winners. These are all prize winners. I should write it this way. All of these individuals are prize winners. Okay, so the smallest, the smallest score needed to win the prize would be 74, which is scored by the 40th individual. And of course, above, from 40 all the way up to 50, all of them won the prize. Okay, so what's the minimum score? Well, the minimum score that's needed is 74. Okay, that's the minimum score. Right, use the diagram to complete the frequency table. Okay, so between 0 and 20, when the score is between 0 and 20, what's the frequency? Okay, so this is the given, you might say, well, this is also a frequency table. This is the cumulative frequency table. Like, you need to work out the frequencies, the individual frequencies of these ranges. So what's the frequency between 0 and 20? Well, the frequency between 0 and 20. Can I take off these 16 and 17 because I want to, or should I do it with a different color? I think I should do it with a different color. So between 20, 0 and 20, what's the frequency? Sorry, what? When the score is between 0 and 20, what's the frequency? Okay, so between 0, and the score is between 0 and 20, the frequency is from 0 to, I think, this would be 14, right? So 0 to 20, its frequency is 14, right? And after that, the frequency would be, let's say, from 20 to 40, the frequency would be Yeah, this is the one I'm doing in blue, by the way. And from 20 to 40, the frequency would be, already the frequency is 13. Okay, so this frequency is already 13. And at 40, from 20 to 40, the frequency is 25, 26, 27. So if you do 27 minus 13, I think you should get 30, if I'm not wrong. Did we do it right? Yeah. This would be 27 minus 13 would be, God, I'm so bad at maths. This should be, I think this should be 13. Okay, next. 40 to 60. 27, 14. Okay. So that's 14. No, no, wait. This is 13. What am I doing? This is 13. Right. And the other one is 25, 26, 27. Okay. So 27 minus 13 would be 14. Okay. And after that, between 40 and 60, what's the frequency between 40 and 60? Let's work it out. Between 40 and 60, the frequency would be this frequency is 35. So what is 35 minus 27? 35 minus 27 would be, I think, 8. So the next frequency should be 8. And 60 to 80, let's say. It's the frequency between 60 and 80. So here is 80. Only focus on the blue ones. So I think this is 40, 41, 42. So 42 minus 35 would be, guys, I'm so, 7. Okay. I'm so tired right now, so I'm using the calculator for small calculations. I swear, only for small calculations. So this is, I think, 7. I'm not wrong. Yes. Okay. A few up and downs are okay. I think this might not exactly match with the marking scheme, but one digit up and down, that's fine. Okay, for 0 and 20, the first one, it says it should be 14. Wow. The first one, it says it should be 14. Oh, it is 14. What am I doing? This one is 14. Oh, God. Yeah, sorry. The first one is 14. Yes. First one is 14. And the other one should be 13. So 27 minus 14 should be 13. Yeah. So this should be 13. 14, 13, and 8 and 7. Yes, this is perfectly okay with the marking scheme now. Yeah, sorry, guys. I messed up. Yes, my fault. Okay, so we're done with question 18 here. Are we? Yeah, I hope so. Yes. So we're done with question 18. Right, let's move on to question number 19. X is inversely proportional to the square root of y. Okay. How would we write it? Well, x is inversely proportional to the square root of y. Okay. When I solve it, if I remove the proportionality, I'll use k. So x equals k divided by square root y. So you put in the values to find out the value of k. When x is equal to 2, y is equal to 16. So instead of x, I'm going to put 2. And y is equal to square root 16, which we know 16 is a perfect square. So it's going to be 4. K divided by 4. K is equal to 8. So our new equation would be, we know the value of k now. So x is equal to, which was previously k over y. Now it's going to look like 8 over square root of y. Okay. Now find y when x is equal to 32. If you put, for x, if you put 32 is equal to 8 divided by square root of y. If I were to isolate square root of y, I'm going to get 8 over 32. If I were to square both sides, I am going to get, well, I'm going to get, okay. So I should get y is equal to 8 over 32 whole square. This is simplified over 32 before. 8 over 32 would be 8 ones are 4. 8 ones are 8, 8 fours are 32. Yeah. So square root of y is equal to 1 over 4. Yeah, that's me being tired. And that's going to happen to you as well when you're During the exam, once you're doing your exam, you are bound to get tired, and that's totally fine. Okay. But do not lose your grit. Okay. Do not lose hold of yourself. Keep on going unless you're done, until you're done with the paper. So if I square both sides, I'm gonna get y is equal to 1 over 4 whole squared. Of course, this square. I don't think you need to do, yeah, let's do that. So you're gonna get square and square root will cancel out, and not very proud of myself right now. Okay, so y square and square root will cancel out. It will be 1 over 16, and that is your answer, 1 over 16. Okay. All right, question number 20. This is one of the interesting ones. I particularly like these type of questions where we'll have to use the laws of indices. Okay. Ax to the power of n whole to the power 2 divided by 3 equals 4x to the power of 10. Work out the value of a and the value of n. Well, let's see. Okay, so if I were to distribute this power inside to a and to x, it's going to look like this: a to the power 2 divided by 3 and a to the power 2 divided by 3, x to the power 2n divided by 3 equals 4x to the power of 10. Okay. Now, if you notice, since the two entities are equal to each other, okay, the two entities are equal to each other, which means x is equal to x, right? So if the bases are the same, you can equate their exponents. Okay, if the two things are equal to each other, bases are also same, which means you can equate the exponents, right? These exponents must also be equal to each other. Okay, the one that I've put in red. So this is going to look like 2n divided by 3 is equal to 10. And from here, I think you can work out the value of n. 2n is equal to 30, n is equal to 30 divided by 2, n should be equal to 15. Okay. Now we are supposed to work out the value of a and the value of n. Let's work out we worked out the value of n. Let's real quick work out the value of a. Okay. So we're done with this. We're done equating this bit. Let's talk about the next one. This should be equal to, I mean, in other words, this whole thing should be equal to this. Okay, let me put that over here. So a to the power 2 over 3 is equal to 4. I want just a over here. So this power, I hope you learned this in laws of indices. This power, when it goes over to this other side, it is reciprocal. Okay. So a to the power 4, this power will be reciprocal, so it's going to be 3 over 2. How does it happen? Let me real quick give you a demo of how does it happen. So if you a to the power 2 over 3 equals 4, take 3 by 2 as exponent on both sides. Okay, so previously it was a to the power 2 over 3 equals 4. I will take 3 over 2 as 3 over 2 as exponent on both sides. 3 over 2, and I'll take this 3 over 2. So the reason that I specifically picked 3 over 2 to be exponentiated on both sides, so that I can cancel out the 3 and the 2, and I'll be just left with a is equal to 4 to the power 3 over 2. Okay, just in case if you're wondering how does it happen, this is how it happens. Okay, I'll take it off. You can note it down if you want to. Again, okay, so a to the power 3 over 2. Well, this is one of the case with the rational indices. I hope you remember rational indices. And how do we deal with rational indices? The numerator becomes the exponent, the denominator becomes the root. Okay, so the denominator becomes the root, so 4 square root of 2, and the numerator, which is 3, becomes the exponent. Okay, if you don't know this, you can go back and check the rational indices. It actually looks like this: a to the power a over mn. This is the law of rational indices. If you know this, you can just skip ahead. Rational index. So what happens if you have a rational index? A to the power m over n is equal to a to the power square root of n and whole to the power of m. In other words, in simple words, it's a really simple way to remember this. The new denominator becomes the exponent. The denominator becomes the root. The numerator becomes the exponent. That's how simple it is. A is equal to square root of 4. We know it's just 2 to the cube, which is 8. So we find out the value of A, which is 8. We found out the value of N, which is 15. And we are done with question number 20. All right. Next question. Question number 21. How many are left? I'm getting tired. So there's 21, there's 22, 23. Hopefully this is the last. 24. 25. 26. Oh my God. Yeah. So 26 is the last. Yeah. 26. So guys, a little more. Stick around a little more. The diagram shows the speed time graph for a journey. Calculate the total distance. This is pretty simple. We know that if you have a speed time graph, the area under the curve, it gives you the total distance traveled. Okay, so if you have a speed time graph, total distance traveled will be given by area under the curve. So all you have to do is calculate the area under the curve. All of the area. So there are two ways of doing it. This is all the area we're talking about. If you want me to highlight, I can also highlight it. I love doing it actually. Yes. Again, so something like you can skip ahead if you want. I'm just doing my nonsense. You have no idea how much pleasure I find doing this. Anyways, yeah, I love it. Acha, there are two ways of doing this. One way of doing it is you find this looks like a trapezium, right? It's a trapezium in a way that, well, it has two parallel sides. You can work out the area by using the formula for trapezium, right? Which would be you just done with this in a single go. Okay, so area of trapezium, if you don't know the formula, I'll write down the formula for you. Trapezium is equal to a half times a plus b times height. A plus b is the length of the parallel sides. So these are the parallel sides actually. I hope you can already tell these are the parallel sides. This side would be A, the whole thing, be A, and this side would be B. Okay, the parallel sides. Trapezium always has two parallel sides. Okay, this is the definition of a trapezium. So you can just add up the two sides and multiply it by height. So the height, this is the height of a trapezium, okay, which I think is 10. So 1 by 2, A is, I think, 10 plus 30, all the way it's 60. So I think I don't have to add this. 60 plus B is between 10 and 30. So B is between 30 and 10. So it should be 20. Okay, 30 minus 10 is equal to 20. Okay, so 60 plus 20 times height is 10. That's the simplest way to do it. A half times 60 plus 20 is 80 times 10. So you could do is, you want to cancel out, you can. Otherwise, you could just multiply. 800 divided by 2 is 400. Okay. Achha, be sure to, yeah, it's just 400. Okay, unit is already mentioned. So that's the area. That's one way of doing it. I hope this is fine. The other way of doing it is, I'll just tell you, I'm not going to do it. The other way of doing it would be to split the whole thing into 3 different shapes. Okay, so if you see, you can see a triangle, you can work out the area of this triangle. You can work out the area of this rectangle, the second shape, and you can work out the area of this triangle. And can add up all 3 areas. Okay, if it sounds nonsense, you could just ignore. Okay, but I think the simplest way to do it is to do it by using the area of a trapezium. Okay, next, work out, we have a function, f of x is equal to, f of x is equal to 3x squared plus 5. Work out f of minus 1, this is really simple. All you have to do is instead of x, put in -1. So 3 times -1 whole squared plus 5. This will be 3 times, -1 squared is just 1. 3 plus 5 is 8, so this is going to be 8. Okay, so it's just 8. Solve f of 2x is equal to, so whenever it says solve, which means normally it requires you to work out the value of the variable. Normally, it asks for the value of the variable. So f of 2x would mean that instead of x, I'm going to put 2x. So 3 times 2x, f of 2x would be equal to 3 times 2x whole squared plus 5. It should be equal to 17. Okay, so I'm just going to take this out of the equality. And so 3 times 2x whole squared would be 4x squared plus 5 equals 17. 4 times 3 would be, this would be 12x squared equals 17 minus 5. Yeah, so 17 minus 5, I think it's 12 already, right? So x squared would be 17 minus 5 is 12. You divide by 12 on both sides. You are going to get x squared is equal to 1. Okay. Now, if I square root on both sides, x will be equal to plus minus 1. Why plus minus 1? I think I'm sure you've been taught this. If you square negative 1, you're going to get a 1. If you square positive 1, you're going to get a 1. Okay? You end up with 1 either way. Okay, so this is how you get by squaring. But if you want to go back, if you square root 1, you're not sure if you're going back to 1 or negative 1. Okay, so this is why we put both the values, 1 and negative 1. So x is equal to 1 or x is equal to negative 1. Right, question number 23. I hope you can hear me fine. Okay, yeah, microphone is working fine. A rectangle has a length 32 centimeters and a width 15 centimeters. Each measurement is given to correct to the nearest centimeter. The nearest centimeter means to correct to the nearest 1 centimeter. Okay, that's the value. If I were to calculate the error, I'll take this and I'll divide it by half. So 1/2 will be 0.5 centimeters. Okay, that's the value of the error. Work out the upper bound for length. So this is the length, right? For upper bound will be equal to 32 plus 0.5. You add the error value, and for lower bound, you subtract the value of error. Okay, so I want to find out the upper bound. Upper bound would be 32 plus 0.5 would be 32.5. So 32.5 is my upper bound for the length. So this is interesting. Calculate the upper bound for the difference between the length and width. Okay, so difference is equal to length minus width. I need to work out the upper bound of the difference. Okay, I'll just put in the arrows. And to work out, which means max as much value of the difference as possible. So how can I get the maximum value of difference? If I take the upper bound of L and I subtract it with the lower bound of the width. In other words, whenever you have a minus, you get a lower. If it's addition, then if I want to work out the upper bound, and if it's addition, you add both the upper bounds. I hope you know about this. Right, so the upper bound of the difference would be the upper bound of length, which is 32.5 minus lower bound of width. We didn't do the upper bound and the lower bound of the width. Let's do that real quick. So the lower bound of the width would be just 15 minus 0.5, right? So 32.5 minus 15.0.5 would be 14.5, right? What is 32.5 minus 14.5? So guys, I'm really lazy right now. I don't want to spend time doing the mental maths because I'm too tired for it. So I'll just use the calculator. I'm cheating. Yes, I'm cheating. It's 18. I hope you can work it out. Right, so it's 18. Right, so we're done with question number 23, and also really simple question, simplify. Right, so what did it look like? What does the question look like? What do you think? I think it looks like, at the top, looks like a trinomial, which we can factorize. And the bottom looks like, well, there's a common factor of x, which we can factor out. So let's work out the numerator. The numerator is a trinomial, which we can factor out. I hope you remember the method. I'll do it separately over here. Okay, in case you don't remember, you take the values of from both sides negative through, and you have to find out a number which add up to give the middle term, which is 5, and which multiply to give. Yeah, we have to find a number which add up to give 5 and multiply to give -6. I think the two numbers should be. What should the two numbers be? They add up to give 5 and multiply to give -6. I think. What could the two numbers be? I think -3. Now what? How about 6 and -1? Yeah, 6 and -1. They add up to give 5 and multiply to get a -6. Yes. So I'll use the numbers to split the middle term in case you know about the middle term breakdown. This will be 2x squared plus 6x minus x minus 3, right? So you take the 2x common actually, and we left with x plus 3. If you take -1, you get 2x plus 3. This comes with 2x minus 1 and x plus 3. That's how you simplify the numerator. Of course, you have to do it over here. I'm just lazy, so I did it separately. Anyway, so instead of the numerator, we just simplified it. I can write 2x minus 1 times x plus 3 divided by, and if you look at the denominator actually has an x common, 2x common on both sides. If I take out the 2x common from the denominator, I'm gonna get, I think, x plus 3. Okay, and I see a very potential target for cancellation. I love cancellation. So, and I'm sure everybody loves cancellation. It just makes things smaller. So x plus 3 will be cancelled out, and I'll be just left with 2x minus 1 divided by 2x. So 2x minus 1 divided by 2x. If you want to further simplify, you can also do, I mean, this is the answer. This works. Okay. But in case if you're curious, if you want to further simplify, you can do it this way. You can do the LCM breakdown. I'm sure you've heard of the LCM breakdown. You can skip ahead if you want to, just want to teach something extra. So LCM breakdown is when you have a plus b divided by c. If you have a single LCM, you can use this LCM to break down the numerator. Okay. So I have a single denominator here, so why not use LCM breakdown? 2x divided by 2x minus 1 divided by 2x. Okay. So 2x, if I cancel out, I'm going to get 1 over 2x. This could also be the answer. Okay, just saying. You should know the LCM breakdown. It's a good thing to know. Helps. Right, so we're done with 24. You can see that I'm trying to hurry. 25 should be the last. Yeah, 26. Okay. This is 3D trigonometry. From the looks of it, I can tell this is 3D trigonometry. Okay, so you have to do it very, very carefully. You might have to draw some extra diagrams for it as well, just in case. Just in case you're wondering. The diagram shows a cuboid. EH is 6. All the measurements are given. Calculate CG. I'm interested in this side. Okay. So if you notice that, I'll make it a small one. Here is a diagonal. Okay. What do you think would be if I were to make it a right angle triangle, what do you think should be my base? I think if I were to make it a right angle triangle, I'll have to connect E to G. Okay. Now think about it in a very weird sense. This is a right angle triangle. Okay. So I need to find out this value, of course. But the problem is, I don't even know this value either. Okay. I don't even know the value of EG. So first of all, I will use another right angle triangle, which is this one, the yellow right angle triangle, to work out the value of 2 question marks. Okay, let's just call it that, EG. And once I know the value of the 2 question marks as EG, I can then work out the green triangle. Okay, so let's work out the value of EG. I think this is pretty simple. You know the 6 and 2, this right angle triangle. You want to work out the hypotenuse. Let's call this Y, shall we? Let's call this Y. Let's call this X. So we're trying to find out a Y first. So y squared is equal to, you can also write I'm talking about the triangle EHG. Okay, I hope you can see the triangle in the at the floor. So y squared is equal to 6 squared plus 2 squared, which is y squared is equal to 36 plus 4. Y squared is equal to 40. So y is equal to, I'm just going to write square root 40. Okay. Right. So y is square root 40. I know this. Now let's work out the green triangle, shall we? The green triangle. Okay. So by using the value of y, which is square root 40, I'm going to say in triangle. So the green triangle is ECG. Oh, yeah, ECG. Okay, so triangle ECG. If you apply the Pythagorean theorem, this is my hypotenuse. I hope it's obvious that this is the hypotenuse. Okay, so hypotenuse is 7. So 7 squared is equal to x squared, which is CG, plus square root of 40 whole square. I need to find out the value of x. So this is 7 squared is 49 equals x squared plus square will cancel out the square root and I'll be left with 40. 49 minus 40 is equal to x squared. 9 is equal to x squared. X is equal to 3. Now you might be wondering if I square root both sides. Let me do it step by step for you. If I square root both sides, I'm going to get x is equal to 9. X is equal to 3. Now, why did I not, right? You might be saying, sir, previously you did, when you did x is equal to 1, x squared is equal to 1. Yeah. When you square rooted both sides, you got plus and minus 1. Why are we not getting plus minus 3 over here? What do you think? Because this is length. Length cannot be negative. Okay, so I ruled out the negative value and I just included the positive value. Okay, length cannot be negative. Okay, so the negative value, so negative 3 is discarded. I'll just say that. Negative 3 is discarded or rejected. Taken. So CG is equal to 3. Right? Let's move on to the last question. I hope this is the last. Yes, this is the last. Guys, stick around. This is the last. Okay, solve. Okay, so my idea of doing it is whenever I get an equation, of course, this is an equation, and when it says solve, which means we want to find out the value of x. Like we talked about it just a while ago. We need to find out the value of x. Whenever I get something like this, a fractions, there is an equation, my number one strategy is ideally, I want to convert this into something which I want to proceed by working in such a way that I get two fractions on both sides of the equation. So that I can cross multiply because I love, apart from cancellation, I also love cross multiplying. Okay, so ideally I want to get two fractions on either sides of the equation. So that's what I'll do. I'll keep x over x minus 1 over here, and I'll send 3 divided by 2x minus 1, the other fraction, over to the other side of the equation. So this will be 1 plus 3 by 2x minus 1. And now what's the way to add the two fractions? Of course, I have not reached this stage yet because there's still two fractions. I want to convert them into a single fraction so that I can do the cross multiplication, right? So a way to, how can I add them up to convert this into a single fraction? Well, sadly, we have to have the same denominators. So the way I can do, one thing I can do is, we have 1 in the denominator, so I can multiply it by 2x minus 1, and I can also multiply the numerator with 2x minus 1. Okay, so I'm going to get x divided by x minus 1 is equal to 2x minus 1 divided by 2x minus 1 plus 3 divided by 2x minus 1. Now, this makes things simple because the denominators are the same, right? So I could just write the whole thing under a single denominator. So I'll be left with x by x minus 1 is equal to 2x minus 1. On top, we have 2x minus 1 plus 3 because I merged the two fractions. 2x minus 1 and added 3. 3 minus 1 is just 2. So I'll just write x divided by x minus 1 is equal to 2x plus 2 divided by 2x minus 1. I hope I'm doing it right. Okay, so my ideal situation has reached. I now have reached two fractions exactly on either side of the equation, right? So what I can do is something that I love doing is cross multiply. Okay, so x times 2x minus 1 equals 2x plus 2 times x minus 1. So that will be 2x squared minus x equals, if I do the distributive property on this one, 2x times x would be 2x squared, 2x squared minus 2x minus 2 actually. What? 2x squared minus 2x plus 2x minus 2. Okay. Right. I think x is equal to 2. Yeah. Right. So what will I be left with? I think I'll be left with okay, let's send everything over to the side of the equation. Okay, everything. Or if you're smart enough to know that you can cancel out 2 squared from both sides, because if this comes over to this side, this becomes a negative 2x squared. Let's just write it actually. 2x squared, the other 2x squared from the other side. So this is the negative 2x squared. And this 2x, negative 2x will cancel out because they're the opposites of each other, right? And so minus x is equal to 2, right? 2x squared and negative 2x squared also cancel out each other. So I'll be left with negative x is equal to negative 2, which is, if you multiply by negative 1 on both sides, it can cancel out the negatives from both sides. So I'll be left with x equals to 2. If you know a better way to do this, you can. That's how I do it. Okay, so x is equal to 2. And that's how we are done. Guys, if you found any value out of it, don't forget to like, don't forget to subscribe. If you guys had fun, I had a lot of fun solving it. I hope you guys had fun too watching it. That's all. Take care of yourself, and we'll see you in the next video.